Today we are going to talk about composite figures. Composite figures are 2D figures that are made up of other 2D figures such as squares and triangles. These are two examples of composite figures. So for example, if I take a look at this, I can break it down into a rectangle and a triangle. Finding the area of this entire figure is going to be challenging, but when I break it down into a rectangle, I know the area formula for a rectangle and I know the area formula for a triangle, so I can find the area of rectangle, find the area of triangle to find the entire composite figure. Okay, so here I also have a square and a trapezoid. So together, keeping those together, trying to figure out the area would be challenging. But if I break it into the two separate figures, I am able to more easily determine what my area is. So these are composite figures. Today, what we are going to practice is how to determine side lengths for composite figures so that we can later find the area. So when I look here, I have a composite figure and I could either break down this figure right here, so I'd have two rectangles, or I could break it down here, so I have two rectangles. Noticing that I have a composite figure made of rectangles. Now, the question is, what is this dimension? If I were to break down this figure right here and had one rectangle and two rectangles, I would need to know what this length is. So what we do is we know that this is 16, and then directly attached, that is 14. So 16 is this chunk, and 14 is this chunk. So I add those two together. 16 plus 14 is 30. So the length of this side, the measurement of this side, would be 30 centimeters. We can take a look at this figure as well and note something similar. So this is 3, which means this is 3, and this is 3, meaning this is 3. So 3 plus 3 is 6. So this dimension is 6 yards. We know, going back to this example for a moment, that rectangles, the opposite side of a rectangle is the same length. So opposite sides of rectangles are the same length. So if this is 16 and 14, this is 16 and 14, combining them equal 30. Same here. I could draw this line here, and then I know that 3 opposite side is 3, 3 opposite side is 3. Super important to remember what we know about rectangles. All right, let's try this one. This one gets a little trickier. So here I have 17. I'm looking for this little guy right there. Now, again, we know that the opposite sides are congruent. So if I were to extend this to be the entire length of this rectangle here, I would be able to know that all of this is 17. Now, I know that this is 14, so then this little bit is also 14. If the whole thing is 17 and this bit is 14, I take away 14 from 17, and then whatever's left is what this length is. So 17 minus 14 is 3. So this dimension here is 3 centimeters. One more rectangular composite figure. We want to find out what this is, and we would see that it is opposite of this 6 yards, so it is simply 6 yards. From there, we could even go and determine what this little guy is. If I know this is 6 and this is 3, 6 minus 3 would leave me with a 3 here. So we break down our figures and we keep in mind that the opposite side of rectangles have the same length. All right, I've got triangles for you now. So if we take a look here, this time we want to find what the base of the triangle is. So we've got rectangles and triangles. So I'm going to break my figure down. So I turn this from a little pentagon into a rectangle and a triangle. But the goal is, we know the base and the height of the rectangle. I need to know what the base is of that triangle. We have the height here. I need to know the base. But because we know the opposite side of a rectangle, opposite sides are congruent, we know that would be 12 inches as well, just like this. This one's slightly trickier. We know that this is 12, so opposite of that would just be this piece. But our base of this triangle is this whole thing. So it's actually 2 plus 12 plus 2. 2 plus 12 is 14, plus 2 is 16. So here, the base of our triangle is 16 inches. 2 more examples for us today. Down here, we've got a pentagon again. So I can draw my line right here. What would my base of my triangle be? Well, it's opposite of that 29, so it'd be 29 meters. And lastly, here, my triangle is going to be sideways. I draw my line. What will my base be? Opposite would get me 10 inches. And then from here, I don't know what this height is then, but what I can do is know this whole thing is 10, and opposite is 5. So 10 minus 5 would leave this as 5 as well. But my base here is 10 inches.